Okay, so we're going to talk about volume and areas of similar solids. And so similar solids have a proportion, the similarity ratio. So it could be 2 times bigger, half as big, 3/5 as big, 11/7 bigger. There's just some ratio that these things go that's common between all the components. And so the key part with this is our areas go up by the square of that ratio, and our volumes go up by the cube of that ratio. So doubling the size of something is going to go up 4 times in terms of area and go up 8 times, which is 2 cubed in terms of volume. So to determine if things are similar, we just have to look at the pieces. So we think square units for area, and if you think cubic units for volume, which is how we measure those two things, you'll keep this straight. So the key thing is that doubling a size doesn't double the area and double the volume. It's a different relationship. So if we're looking at these two and want to figure out if they're similar, well, I look at this radius down here, it's times 3 to get to 9, that's okay. If I take the height and multiply it by 9, I'm not going to get 26, I get 24. So these are not going to be similar. They don't follow a similarity ratio. So we would say no. We're often given that things are similar, and then we have to figure things out from that. So we're given areas, and we want to find the ratio. So we're going to compare the two quantities. The ratio is something, A over B, and the ratio of the areas is squared. So then I can take my areas and set that equal to it. So instead of just the ratio of areas, I have the actual areas. That's 98 pi over 2 pi. If we reduce that, we cross off the pi's and reduce 98 and 2, I get 49 over 1 is something squared. The way that I get rid of the square here is to take the square root. So I'd square root both sides, and I get 7 over 1. That's my ratio. This is the same as this. Okay? So it's not just taking a direct comparison of the areas. You have to realize that whatever your ratio is has been squared for your areas. All right? We have a similar one below where we're talking about volumes. So I have some ratio. When I cube it, then I can talk about my volumes. So now I have 48 over 162. And it's going to be really critical that we reduce this all the way. A lot of these are going to work out pretty well if we reduce them. So that's 8 over 27. And we need to recognize that this is a perfect cube and this is a perfect cube. So we're going to take the cube root of both things. This works out to be the cube root of 2 to the third over 3 to the third. So those cube roots and those cubic powers cancel each other out, and you're left with 2/3. That becomes our ratio between them. We're not asked to figure out the ratio, though. We're asked to figure out the surface area. So if we look for the surface area, we know that our ratio is going to get squared. So this 2/3 becomes 2/3 squared. And I can use that to set up a proportion. So I know that my larger pyramid is 135. 3 is bigger than 2, so this has got to go on the bottom here. 135 is on the bottom. Over something, that's what I'm trying to figure out. So now I take 2/3 and I square it, and I get 4 over 9. Times 135 because I'm solving for this piece here. So I'd multiply by 135, and now it's pretty simple. I just plug it in a calculator, reduce it, and I get 60 is the area of my smaller pyramid. All right. So again, what we did, we knew we had a ratio. It was cubed because we're looking at volumes. I found that ratio, and then I squared it because I'm looking at areas, and then I can set up a proportion and solve that to make it work. All right. For the next one, it looks maybe a little bit different, but we're talking about some dimensions of a rectangular prism, and it says it holds 25 pounds of detergent. So that holds part is a volume problem. We're not talking about area, we're talking about volume. And so we're going to have to take our ratio and look at a cube factor of it to be able to solve this. So there's my ratio. I'm just looking at the 6 inches high versus 8 inches high, but since I'm talking about volume, it's going to get cubed. And so that's this volume, my smaller one, over something, which is my larger value. So now I plug through it. I just cube 6 and I cube 8 and cross multiply. If I reduce it first, it's maybe a little bit easier. So I get 27 over 64 is 3.25 over x. Cross multiply, and you're going to get that x is around 7.7 pounds. So I'd hold around 7.7 pounds of material by going from 2 inches, a 2-inch difference in the height of detergent.